Section 5.6 is about inequalities in two triangles. The section starts with a theorem and its converse. So the first theorem is theorem 513, the hinge theorem. It states if two sides of one triangle are congruent to two sides of another triangle. So if you're looking at the diagram, this side is congruent to this side, and this side is congruent to this side. And the included angle of the first, so here would be the included angle, is larger than the included angle of the second, so this one's 88 and 35. Then the third side of the first is longer than the third side of the second. So what they're saying is the length of XW would be bigger than the length of TS, since 88 is bigger than 35, and those angles are formed by congruent sides. So if I told you that this length was 10, then you would know that the length of TS would have to be less than 10. Moving on to the converse of the hinge theorem, theorem 514. If two sides of one triangle are congruent to two sides of another triangle, so it starts off just the same as the last one, so one side's congruent to another side, and one side's congruent to the other side. And the third side of the first is longer than the third side of the second. So you can see here that this third side is 12 and this third side is 9. Then the included angle of the first is larger than the included angle of the second. So since this side is 12 and this side is 9, that means that angle C is bigger than angle F, which is exactly what it says here. The measure of angle C is greater than the measure of angle F. So if this side's bigger than this side, then you can conclude that the angle opposite is going to be bigger when it's across from the bigger side. But again, you have to start off with congruent sides with that included angle, just like you did with the hinge theorem above. So let's move on to see an example. So let's start with example number 1. Given that segment BC is congruent to DC, and notice that it is marked in our diagram, how does angle ACB, which is this angle right here, compare to angle ACD, which is this angle right here? So thinking back to the hinge theorem, we know we have to start off with two pairs of congruent sides. So we have one pair, the BC and the DC, and we also know that segment AC is congruent to itself. So now we have two pairs of congruent sides, just like the hinge theorem wants us to start off with. So since we have two pairs of congruent sides, then we're going to look at that third side. So in this case, AB is 16 and AD is 15. Since 16 is bigger than 15, you would conclude that the angle opposite the 16 would be bigger than the angle opposite the 15. So the measure of angle ACB, which is the angle that is opposite the 16, would be greater than the measure of angle ACD, which is the angle opposite the smaller side, 15. And we'll finish up this section with example number 2. Part A, if PR is equal to PS, and again that is marked in the diagram, PS and PR are congruent, and the measure of angle QPR, which is this angle right here, is greater than, so bigger than, the measure of angle QPS, which is this angle right here. So this angle is bigger than this angle. So I'm going to mark that in my diagram. Now the question asks which is longer, SQ or RQ? So they're asking, is this segment longer or is this segment longer? Since this angle is bigger than this angle, according to the hinge theorem, we would conclude that RQ would be bigger than SQ since it is opposite the bigger angle. So again, RQ is the longer segment. Moving on to part B. If PR is equal to PS, just like we started in the last problem, and RQ is less than SQ. So let's mark that in the diagram. So again, RQ is smaller than SQ, which is larger. Angle RPQ, which is this angle right here, or angle SPQ, which is this angle right here. Since the bigger side is over here, we would conclude, according to the hinge theorem, that the angle opposite it would be the bigger angle. So the angle opposite the bigger side would be angle SPQ. And that's it for this section. Super easy. So as always, if you do have any questions, we can cover it in class before we move on, and we'll see you then.